So far, all of the equations we've looked at have been of the form trig function equals number. But these aren't the only ways that these equations can show up. And so we're going to start stacking together multiple ideas. And these are going to get really complicated. But if you think about the individual steps, these are all things that you have either seen or done before, or very similar to things you have seen or done before. So let's look at an example. Let's say we have 3 cosine of 2t plus 1 is equal to cosine of 2t. When we first look at this equation, you can see there's a lot going on. Now, similar to when we're solving basic linear equations, you can see, well, first of all, there's nothing being squared here. And so we're trying to figure out how to isolate the variable. Now, in this case, the variable is inside of the function. And so in order for us to get to that, we have to first isolate the function. So let's see what we can do. We can subtract the cosine, give us 2 cosine of 2t. And then we can subtract the 1 equals -1. And then we can divide both sides by 2. Cosine of 2t is equal to -1/2. Right, so you can see that these steps right here are just the same steps we use to solve linear equations, except that instead of solving for x, we're solving for this whole expression, cosine of 2t. And that gets us to here. So that's the first bit of complication. Being able to understand that we're isolating the entire trig term and then using that to get to something that looks familiar. Now this form right here is familiar with the exception of this 2t in the parentheses. We'll deal with that in a moment. But let's take a look at the picture. We have our unit circle. Cosine is the x-coordinate. X-coordinate is a -1/2, so that's going to be this. We're expecting solutions in the second and third quadrant. What's the next thing? Well, then the next thing we have to do is think about, well, what is this reference angle? Because that reference angle is going to help us get these other values. So cosine of what equals 1/2. And so you have to think about that chart. And when you think about the chart, you should see that you have pi over 3 as the reference angle. And so this tells us that the angle is going to be either, well, pi minus pi over 3, so it's going to be 2 pi over 3, or it'll be pi plus an additional pi over 3 for 4 pi over 3. And then we also have plus 2 pi k because of the coterminal angles. The question is, what goes on the left-hand side here? Because this isn't going to be t. It is this angle. This angle is what equals, well, 2 pi over 3 and 4 pi over 3. That angle is 2t and not t. So cosine of whatever this angle is -1/2. Whatever this angle is has got to be one of these values. And so this is the second thing that can happen. When we have a coefficient in front of our variable inside of the parentheses, we get to this point. We still have not solved for t. We have to get the t completely isolated. And so to do that, in this case, we just need to divide both sides by 2. So we're going to look at the top line first. You can see if I divide by 2, those 2 end up canceling out everywhere. We get pi over 3 plus pi k. Down here, we divide everything by 2. 4 pi becomes 2 pi. 2 pi over 3 plus pi k. Again, where k is an integer. And so you can see this has gotten a little bit more complicated, but the ideas are still generally the same. This right here is like solving a linear equation. You know how to do this. You know how to isolate a single variable. You just have to get used to the idea of seeing cosine 2t as the single variable that you're solving for. That gets you to this line right here. This was the new thing that we've introduced in this section. How do you actually solve these trigonometric equations? It's this diagram here. Think about the reference angles. In this case, it was a known value, so we don't even have to go to the calculator. And we get these results. But this value right here gets carried here. There is still more work to do. We have to divide both sides by 2 to isolate the t. Excuse me, and that's how we get this. So here's an example using a word problem. The depth of water at a dock rises and falls with the tide, following the equation f of t equals 4 sine of pi over 12 times t plus 7, where t is measured in hours since midnight, and then the depth is in feet. At what times will the depth be 9 feet deep or deeper? So there's a lot of words going on here. The thing we want to focus on is the equation. So we have this equation, and we're curious as to when this is equal to 9 or more. So we're going to specifically focus on the equals to 9, and then use a graph to sort of figure out what the in-between times would actually look like. So f of t equals 4 sine pi over 12 times t plus 7, and we're saying that this is equal to 9. We're asking, where is it exactly equal to 9? 4 times the sine function plus 7 equals 9. This is a linear equation. 4s plus 7 equals 9. So this is 4 sine of pi over 12t is equal to 2. So divide both sides by 4. Sine of pi over 12t is equal to 1/2. Fortunately for us, this is a known value from the unit circle table, so we can just use our values from that instead of having to go to a calculator. We should always, always, always draw this unit circle picture just to sort of keep all the information straight. So our sine value is the y-coordinate, and then it's equal to positive 1/2, so it's up here. So we're looking for an angle in quadrant 1 and an angle in quadrant 2. What is the corresponding reference angle? Sine of what reference angle is equal to 1/2? And you should see that sine of pi over 6 is equal to 1/2. So this angle right here, pi over 12t, there are two possibilities. There's going to be the pi over 6 possibility for this side. Using reference angles, that's going to be pi over 6. And so since from here to here is pi, and that's pi over 6, pi minus the pi over 6 is 5 pi over 6. Now, at this point, we have to sort of make some decisions. Are we interested in all the solutions or just this first, the solutions going around the circle the first time? And since this is repeating every single day, and we're not looking at multiple days, we're just looking at this one day, it's good enough to leave it here. But this is a decision we have to make based on the problem itself. It's not some decision that we make in advance or that we always do one thing or something else. It's relative to this problem. This problem, we're just looking for the hours on a particular day, and so we can just restrict this to one loop. So anyway, we're now trying to solve for t. So t is equal to, I'm going to multiply by 12, divide by 5. So dividing by the pi cancels out all the pi's. Multiply by 12, 12 over 6 is 2. And then here, multiply by 12, 10, 5 times 2 is 10. So 2 and 10. What does this mean? Let's think about the picture. Here we have a sine function. The midline is at height 7. So there's our midline. This 4 corresponds to the amplitude. There is no shift term, but there is a compression term by a factor of pi over 12. That's actually, since pi over 12 is less than 1, it's actually expanding out this way. But the basic idea here is that it's going to start at the midline. It's going to go up, down, and up like this. What is the period? Where does it actually repeat? Well, there are two ways to think about it. One is that this is how it happens every single day, so you know that it repeats at 24. The other thing is to know that the period is 2 pi divided by b, so 2 pi divided by pi over 12, multiplied by the reciprocal, 2 pi times 12 over pi, and that is equal to 24. So either way, we can see that that's where it repeats. We're interested in where this is equal to 9. 9 is bigger than 4. So we have this point here and this point here, which correspond to 2 and 10. So what does this mean? This means that the depth of water will be 9 feet or deeper from 2 a.m. to 10 a.m. And this is how we can put the pieces together here using this problem and think about solving the equation, that's this part, but then also interpreting and understanding the result.